take it. You want to take it from here?
Sure, I'll go ahead. Hello, everyone. Good day, everyone. I hope you can hear me okay. If you can't, just put a message in the chat window, and we'll see if I have some technical problems or not. Hopefully not. What you see on the screen out here is the part we're going to be programming. It is a what you can consider a mold core insert, where it's setting on a plate. This is the insert plate, and the core is machined out of that plate. What you're looking at here is the prototype configuration. I'll be looking at the possible production configuration as well. So just some general points here that types of machining we're going to be using. We're going to be doing some initial horizontal roughing. I'll rough this down. We're going to do some step minimization, which actually combines a re-roughing into a horizontal roughing all in one operation. It's pretty interesting. Then we're going to do some 3-axis pre-finishing. So we're going to work it down with a little bit of stock left over, and then we're going to do some additional parallel finishing in both the X and the Y. We'll be looking at horizontal finishing for the walls that are nearly vertical, and we're going to be looking at 2.5-axis profiling as it compares to 3-axis, and what we're going to be doing in 3-axis. So we're going to show the difference of the two and why one is obviously better than the other. So let's go ahead on to the demo portion, and let's bring up our part here. Okay, so what I got on the screen here, we got the orthographic views, top, front, right, and perspective. I'm going to go into the perspective view. Okay, and just to look at what I got over here on the layers, we've got mold plates. These are the 2 mold plates right here. This is our insert with our core. And we've got one surface for a masking surface that's going to mask out these holes so we don't machine them. And we have some section views that we have cut just to get an idea of what the shape of this part in different areas. Okay, so what I'm going to do is I'm going to go ahead and turn off the mold plates. Okay, so we have basically the way mold inserts work. You have two diagonal pins for alignment of the plate, and then you have screws to actually fasten the plate fasten the insert to the plate, the mold plates itself. Okay, so what do we have? The first thing you need to do in any CAM project is you got to get really familiar with the geometry that you're going to be programming, obviously. So what is important with this particular set of geometry? Obviously, you have a lot of complex surfaces in here with some fillets. That's not really nothing that we see here is really a problem with programming it as far as the surfaces up here go. The primary area of concern, and you'll know this, especially if you're a mold designer or a mold machiner, is this parting plane. So we have the core, which extends above the parting plane, and we're going to be paying attention to this transition area right here. And you're going to need to ask yourself, as you look at your geometry, where on this geometry am I allowed to have fillets? In 3-axis machining, when you have contoured curves like this or contoured surfaces, it's difficult to get an exact sharp edge. Okay, so you need to find out what is acceptable as far as a fillet. How small of a ball mill can you use to get in there? What's acceptable to the mold design and your customer, etc. So we're not going to be worrying too much about these edges here. We're going to be just including them in the programming of the main body itself. but you do need to find out what is acceptable for the mold. Now remember, this is a prototype version, okay? So this edge, you may have some leeway, and you may be allowed to put a small fillet in this edge, which in a prototype production just means this is the inner core. So this edge is going to be the inside edge of the cavity. So you may just have a little fillet in there, which may be acceptable as far as prototyping goes. But we're going to pay special attention to that as we program it out. Now, we do have a little bit of more time than we usually do in the webinar, since we're using the standard configuration. We're going to be going through this relatively faster than we normally would in a professional configuration. So I'm going to go ahead and pop over and show you what this would look like in most likely case in a production scenario. So I'm going to bring over this right here. Now you see that we have the same core insert. We have the insert plate with the core surfaces on top. We have the mold plates here, and I'm just going to hide those. Okay, so what will most likely happen for a production environment for this mold insert is that you really want to get a sharp edge there, because that's what the part requires at the parting plane or the parting line. So you really need to maintain that sharp edge. In order to do that in a production setting, you probably don't want to machine it the way we're going to machine it for the prototype. So what they will probably do is wire cut that shape out. So what they'll do is they'll mount this the mold plate, or this is actually going to be a whole block, okay? And we'll probably wire cut. What they'll do is they'll probably drill a hole right here, since this is not a part surface. They'll probably drill a hole here to feed the wire through, and then they'll wire cut it around. So let's take a look at what that looks like. I'm going to go ahead and hide this. Again, if you got any questions, put it in the questions panel. Okay, so in most likely cases, when they wire cut it, anytime they cut anything in a mold shop, they're going to be cutting more than one. So they always cut in sets. In case something happens to one, they can use the second, or they may do 3 sets. Okay, so to get this sharp edge, in most cases, I have it programmed out, but I'm not going to program it in this. I'm going to program it in the prototype. But they'll probably just machine, on down as if this is a part surface, okay? And they'll just machine past this parting plane right here, which is no longer visible now. So one way they might do it, and the way I'm going to do it in the prototype, I've got a number of ball mills, starting with the 3/8, a 1/4 inch, and a 1/8 inch ball mill. So we'll be working it down. So one question you may ask yourself, do I want to machine down to this? You can consider this a fixture, okay? Because that's the wire cut part of that mold plate, and your core is going to be mounted on that, okay? So they've got a couple of pins here, which will align it with the core, and then you have some fasteners, cap screws that actually fasten it in place. So if you're only machining one set, then you really want to pay attention to how you're going to machine at this parting plane. You probably don't, you can consider this a parting line, even though it's a parting plane, because you do have a line between the fixture portion and the core portion. So you may not want to have the tool actually run down on this fixture. You may want to maintain the tangent of the ball mill to stop at the actual parting line. Okay, so in order to do that, an easy way to do that is to use catch planes. So you may have seen us do this, or you may have done this for a number of purposes. And in 3-axis machining, every surface that's visible is taken into account when the tool paths are calculated. So if you have a surface here that's visible, the tool obviously is going to stop on that surface. It's not going to cut below it. As you can see here, we got some offset curves we're going to use for different tool sizes. So what this is going to do is this catch, or spelled catch wrong, catch 3/8, is the 3/8 ball mill is going to stop on this plane, which means that it's 3/8 of an inch below the parting plane. So it's a 3/4 inch ball mill, and the tangent of that ball mill with this catch plane is going to hold that tangent right on the parting plane. Okay, so you got different planes for different ball mill sizes. So we got a 1/4 inch. Okay, so this is a 1/4 inch below the parting plane. This is going to be using a 1/2 inch ball mill, and then we have another one for a 1/4 inch ball mill. So they're in just different levels, which keeps the ball mills tangent to the parting plane. Now, if you're wire cutting out more than one, which is actually what will happen, you can just ignore this method and just machine down, say, a 1/2 inch below this, like in a horizontal finishing operation, to match this profile, and it'll give you a nice sharp edge right there. Okay, I just wanted to go into that just so you'd understand the different ways you might want to approach this particular insert. So I'm going to go back over to my start part here.